All right, so today we're going to be looking at finishing up looking at panel schedule HP1 and then building our riser based on how everything's going to be circuited. Hopefully this video will be a little bit shorter than an hour or so. But as always, if you do have questions, please ask along the way because that's kind of the whole point of this instead of me sitting here talking. In between videos, I did find a pad mount pad mount transformer. I found this off Schneider Electric. Just kind of filled out a little bit of information, downloaded it, and this will work. More than likely, the client out there will have pole-mounted transformer. It's just a little bitty single-phase looking thing. But since the way that we have things set up here, it's just easier to show this for AutoCAD. For Revit purposes and for YouTube purposes, and the utility out there is going to be taking care of this anyways. Like you start basically at the manual transfer switch right here. So, all right. So the last thing we looked at was we walked through the panel schedule LP1. We talked about the rearrangings, the connected load, the demand factor. What amperage are we looking for on this 100 amp panel? What's the max? MCB, so on and so forth. So if you got questions over that, go back to the last video, and let's look at HP1 real quick. So on HP1, there shouldn't be much because we're powering the transformer that feeds LP1, and we're powering lights in the cabin at 277. So most of the time, all this stuff will be filled out. Actually, we'll probably go and do that now just to be safe. And then mains type will be, we want this as an MCB just because we do. And then supply from will be filled out and location is outside, which should automatically be filled out assuming that you're using spaces. These numbers right here, the VAs, are all going to be essentially the same. Okay, let me phrase that. The VAs on the TX1, which is our dry top transformer, are going to be the same as LP1. So for instance, 5618 is going to be 5618 right there, and so same with here. And so let's go ahead and go to the power plan, and we're going to label these things just so we can kind of get an eyeball for what we got. And so if you remember, this was an out of the box project. I did actually wind up dragging a equipment tag in here, and this is apparently what it looks like because I haven't modified it, but I don't want it to just show whatever 7 is. I want it to show the panel name. I'm gonna add a family. This is going to be what it's showing. This is a label, which you can tell right there, which is shown right there, and I want it to show panel name. And I just happen to know that's what I want. Obviously, there's a whole bunch more stuff in here you can show. It's really awesome. All I care about is panel name. Put it into the project, write existing, and that looks about right. Okay, I don't want a leader, so I'm gonna take that off. And you can do that one by one, or whenever you go to actually tag it, before you tag it, stick it right there. Just like that. Let me get my thing a little bit closer. There we go, utility transformer 1. Okay, so from the actual physical install, how this is all going to work is the utility transformer is going to feed the manual transfer switch. So in the real world, there's going to be an underground conductor, conduit and conductor from right about here to the manual transfer switch, from MTS to HP1, HP1 to TX1, TX1 to LP1. That's why it's laid out in this configuration. That's how that's actually going to work in the real world. So since we have all this information now, let's go ahead and make us a riser diagram. What I did was this one. I brought in all of my riser symbols that I've been working on. These look exactly like what our company has, but I've actually added a few extra parameters, You would never know it, the difference between, what is our company's and what mine is, other than small minor things like I centered this top box on this bottom box. I made this diagonal line actually meet the corners, small stuff like that. But generally speaking, contractors aren't going to be able to tell the difference between mine and our companies. For the people on YouTube, there's a lot of information on here for, stated if you've never built these families, whatever else, that can be an entirely separate video. I'm not going to go down that road, but I will actually quickly just kind of click on these. That way you can see the various things that are associated with them. And another quick cheat code, if you will. So a lot of people get frustrated because this little checkbox is so sickening small. It's really hard to click, especially you got fat fingers like me. If you just get into this big box and you hit your space bar, if you just hit your space bar, it will sit there and go back to 4. So that makes it a lot easier. And that trick actually works with a lot of things. If there's little bitty checkboxes that are hard to hit, spacebar seems to work quite well. So this is enclosed circuit breaker, fire pump, obviously, generator. So this is all for the people on YouTube. So you can pause the video if you need to.
I'm assuming this is kind of just an overall question between doing the riser diagram and then your like floor plan layout. I'm assuming on your floor plan layout is where you worry about clearances and everything for equipment to make sure you're placing them in the right spot. But for your riser diagram, you're not really, it's just a diagrammatic thing to show show how things are connected because you don't show that on the floor plan. Is that correct? Like you're not going to show specific, you're not going to make sure equipment specifically laid out with clearances or anything on your riser, right? But you will on your floor plan?
That is an accurate understanding. Yes, that is very accurate.
Okay.
The only thing I would say about clearances on your riser is if you use what's essentially like a grid pattern, it makes it look so much cleaner, so much more small, so much more neat, and so much more easy to manipulate in the future. And I'm about to show you exactly what I mean about that. Excuse me. So the first thing we had was the transformer. Now, whoever is on YouTube watching this, your transformer may look different in your company. This is just the generic one that our company uses. I'm going to go ahead and fill that out of, hey, look, this is your tool, transformer 1. And the secondary voltage is actually, let's do 470 to 480 slash 277 volt. And then I'm just going to say this is a 225 kVA because why not? There you go. So that's what that looks like. All right, so from the pad mount transformer to the MTS, and I will make this look pretty here in a few minutes. ATS name was, got it over here, MTS. So yes, ATS and MTS, essentially the same thing, except ATS is an automatic transfer, whereas MTS is a manual transfer. Not a whole lot of difference other than you got to physically go out there and move a handle. Is that like a 100 amp? It's HP1. Yep, 100 amp. Okay, so we want this to match our panel, right? Poles. Okay, so in a manual transfer switch, you can get either 3-pole, 4-pole. That is a very deep and in-depth discussion, but the short version is that you're going to want 4 poles when you have a generator going to this thing, and you want 3 poles when you have like another utility source. It's a very long conversation. This is the 100,000 foot view of that. Okay. Okay, so I want this thing flipped because my normal is on this side, and I want it don't want it pad mounted because it's on the wall. Okay, so from the MTS, we got HP1, which is panel. So we're clean this up, nice and pretty like. We got a transformer and another panel. Essentially what we got, right? So that looked pretty and that looked pretty. Okay, so now I get rid of that and actually see this stuff. I'm gonna have that. That'll go there. We'll just stick it there for now. All right, so what I was talking about earlier on the separation. So what I normally do is I'll have, so on a 1-to-1 scale, which is what I've got, I'll have, 2 inches or something, whatever looks about right in distance. That may be a little bit too far. That is too far. And it's literally just kind of an eyeball thing. Actually, I'm sorry. Let me back up a little bit. I completely jumped head over heels into this and didn't preface any of this because I got lost on HP1. In schematic design narratives, if you have them, somebody will have already built this and you will just have to modify it. Somebody will have told you, yes, we're pulling from a transformer and we have, we have an ATS or we have 5 ATSs and we have 3 generators and we have this and that. And generally speaking, a schematic design narrative will have all of this kind of sort of laid out. And as you are doing your design in the CDs, the construction drawings, you will need to modify what they provided because they just took kind of a swag and said, generally speaking, this is what we're going to use. So that's how that's going to work. Most of this is already going to be laid out. Obviously, we don't have that. Okay. Second is when you are drafting this, you need to have this already put on a sheet. Okay. So just so that you can make sure that your layout is the right width, length, because if this thing gets really weird, do that from here. There we go. If I change the scale on this, it's going to go kind of weird. See? So this is what you don't want. You don't want it looking all weird. Whether your company does 1-to-1, whether they do something else, this is what I always put on here just to kind of get an initial swag of what this is going to look like.
You'll show on this though not to scale, I'm assuming, for your riser. Like
yes.
You are scaling it, but when you put it on the drawing, you're going to put not to scale because it's not, right?
Yes, correct. It is not to scale. These things are drawn to. I think I actually drew everything off the panel board. Like, okay, our company's panel board was like 3 inches wide or something like that. So, okay, well, now that I've erased everything, great. This is 3 inches wide. This is going to be 6 inches wide. This is going to be 4 inches wide. And the same thing with the counts of the height. So that's essentially how that worked. So let's just say, let's do 1 inch. Keep it simple. And then I can take that and just kind of literally just keep on moving it down. God, I've been being too long. I keep using the wrong stinking commands. Okay, so these are all essentially 1 inches apart. I think is what I had, right? So when you do this, it makes it look nice and pretty.
You did, I don't know if you noticed this, but you took, I know it's not like that important, but from the first panel, which was HP, to the transformer, then to the transformer to the panel, you measured to then to the pad from the one on the left of the transformer, but then for the one on the right of the transformer, you measured to the physical transformer. So your distances are a little off. It doesn't matter that much, but just so you know.
Yeah, well, thank you. I appreciate that. Yeah, the short answer doesn't really matter. Yeah, apparently I don't have my updated versions in here because I've got So, you see where I can snap to this line, but there should be a line right here coming up. Apparently I don't have that in there, and I don't know why. I thought I had updated these, but apparently not. So you can snap to the stuff like that. So in another video, eventually I'm going to show y'all how to, yes, you can add snaps in here, because that is actually a Revit flaw that works in the drafter's favor. You've got to go find the right reference plane to put into different family types in order to be able to snap to it. So, and you got to pull it from like the view title or something like that. So open the view title family, copy that reference plane, and then you can put it into like stuff like this, annotation drawings or annotation symbols. So, anyways, long-winded version of that. All right, so on this stuff, it's literally going to be, hey, like, we're coming down, and as you're drawing this, try to make it look pretty, make it have decent dimensions. Don't just kind of throw random stuff in there, okay? So, like, you saw me come down 3/4 of an inch. Well, if you're just kind of throwing random dimensions in there, it's not going to look good. It's not going to look pleasing to the eyes. So some dimension, use it. Doesn't matter. Just some sort of dimension. That's what we need. Does that make sense?
Yes.
Okay. All right. Now, if this stuff was inside, I'm just kind of showing you quickly, you would have, this would be, I don't know, electrical room 101 or something. I'm just going to kind of throw something in there for, generally speaking, not really applicable to us right now since we're not in here, but I at least wanted to show you. This is kind of the idea of what it would look like outside, exterior, something to that effect. So you would say, hey, look, this is stuff in electrical room 101. And then if you had a second level, you put all that stuff up here showing what room it was in, so on and so forth. Questions on that?
No.
All right, so this is what the riser diagram looks like, even though I didn't fill out the. Okay, so for people on YouTube, you're going to see this stuff magically filled out. All right, so there we go, magically filled in. All right, and since I don't want my scale to actually show 1:1, I'm going to change that to NTS. Display name, NTS, something like that, not to scale, and it magically goes away. All right, so this is what this looks like. A lot of the time, at this point in time, somebody would size they would size the feeders. Put a keynote or a text or something for this one, for this one, for this one, for this one. You either have the text up here of what it is or the keynotes down here sizing it. I'm not going to go through all that right now because we're not sizing stuff. We're doing drawings at the moment. And the next thing is that we need is to pull in these panel schedules. There's HP1 and LP1. Okay, so at this point, now that I got these all nice, pretty, I'd get the layout looking decent. And then verify, now that I've actually drawn my riser, I'd verify the information on my riser versus my panel schedules. For instance, if this is an MLO 100 amp, then this should be MLO 100 amp. And the name should match verbatim. On the previous video, I noticed that this was LP-1 and this was HP1 with no dash. So I went ahead and erased it, the dash in the LP-1. So, and you don't want, you don't want that weird looking stuff. You also want to take a closer look at your riser. For instance, this one, I typed in KVA for my my rating, but I don't need to because it automatically fills out. So yeah, you would just take a quickly look like that one. I don't need to have a volts there. Need one there, and there. So quickly look over that. That way, your engineer of record or whoever you're doing this for doesn't look at you like you're a moron because you have 30 kVA. All right, I understand this is a very basic, simple riser, but that's just kind of how that works. If you need future references for more complex risers, I can definitely show you that. This is the bare basic riser. So
But like you
that's
said, on your risers where you would show sizing, we're just not doing it for these purposes, but you would typically show your sizing on your
sure.
riser diagram.
Yeah, this would be, to say 3 number. I have no idea. I'm just kind of threw something out there. Create ground in a 1 inch, let's call it a 2-inch conduit. So I want to leave it on that. This is one of like the several ways to do this. Something to that effect. Does that make sense?
Yeah.
And I've started leaning towards, doing it like this. Yes, it makes it a little bit more messy, but I've been bitten too many times by saying, hey, well, this thing and this thing are the same size, so I can just call that, cable 3, and then cable 3, I'll call it down here, or whatever. It's a number 10, 3 number 10s, whatever else. And then I realized, oh wait, I need to change the size of this one, but not change the size of that one. Well, I'll change cable 3 down here, and it changed both of these, and I messed it up. So I'm starting to lean towards every single individual run needs its own cable tag, as it were. Where this is EO1, EO2, EO3, EO4, whatever. There's 5 or 6 different things you call this. Do it like that, or just do straight up text. So that's my recommendation. It adds a lot of cable tags. It adds a lot of stuff, but don't try to use the same cable tag in more than one place for various reasons. So it's hard-earned knowledge. So yeah. That's pretty much all I've got for today, because everything else is going to be. Let's see what we got so far. Good power and lighting, riser schedule, site plan. Yeah. Next,
You
go ahead.
so I know like electrical documents have like riser diagrams and like single line diagrams. Is there ever a scenario where you do one and not the other? Like, or do you always need both to have all of the information you need on the drawings to, for a contractor? Like, because at the end of the day, all of this is for a contractor to be able to understand what they need to do for the project. Do you always need both?
It
I
depends
mainly
on the.
ask because I feel like they kind of do the same thing. I'm gonna say it that way.
Yeah, and that's understandable. I normally don't do single line diagrams a whole lot anymore, unless it's a industrial project or water wastewater project. Like when the client understands, knows, and is very good with electrical stuff and will be troubleshooting their own things, single line diagram, period. Like, single line and riser. They are very close. You're correct. But the single line diagram offers more of a troubleshooting advantage, so that if something goes wrong, or if they need to secure power for somewhere, then they understand what they're looking at. Because a single line diagram is going to have, breaker sizing, depending on if it's on the same sheet or relatively close. At that point I would be using cable tags. Like this would be EO1 and this is EO2, and I would have the cable tag schedule over here, and on another sheet I would have the single line diagram and literally use the exact same cable tag schedule. That way there's no problem, no issue. So yeah, the single line diagram does show additional things, but I don't ever use it unless it's like an industrial water, wastewater, stuff like that.
Gotcha. Because for something like for this example, like it's probably isn't necessary because you're going to have enough information to get what this project needs for the contractor. But in specific projects where you probably want more information on the drawings, you would use both, or at least just use the single line.
Yes,
Okay.
I would agree with that statement.
Gotcha.
All right, so looking at this, we don't have E10, 100, 101, 102, and we don't have any details. So over the next couple of these videos, we're going to be doing, okay, you know, stuff like, let's clean this up, let's make it look good, let's add some notes to the contractor so that they understand what our thought process is. Same thing here, you know, make this look a little bit prettier, add some notes as needed, whether they're general notes, key notes, add some details if I can think of any details that we need. And then we'll also add our note symbols and abbreviation page and our specifications, our sheet specs. And I'll go through the differences of what those are, primarily for the people on YouTube, but you know, also in case you don't know. That'll be what's coming in future videos.